Yes, class. So, in the last class, we started with magnetic Lorentz force. So, we had seen that if a charged particle is present in the influence of electric field and magnetic field, both the fields are present. So, we'll calculate the force of electric field as well as we'll calculate the force of magnetic field. Then we'll add up these. Now, straight away, if you have a charge like this question, a particle of 2 coulomb is moving with a velocity. Velocity is I cap minus 2j cap in a region having electric field 2I cap minus 3j cap and magnetic field I cap minus j cap minus 5k cap. Now, instead of calculating it separately, directly you can use the formula or you can directly add it. How? Take the charge common, add electric field to what? To the cross product of velocity and magnetic. So the first task is to find out their cross product. Velocity is I cap minus 2 j cap and magnetic field is I cap minus j cap minus 5k cap. So we'll form the determinant system. We'll use I cap, j cap, k cap. Now we'll use this for velocity. So this is 1, this is minus 2, no k cap, so 0. For B vector, this will be 1, j cap is minus 1, k cap is minus. So V cross B means first I cap. Cut these two, just focus on these 4. So what we do, vertically downwards means minus 2 into minus 5 minus 1 into 0. This much of I cap, right? Now for J cap, I have told you we put a minus in advance. So I gone, J gone. You are left with 1 into minus 5 minus 1 into 0. So 1 into minus 5 minus 1 into 0. This is J cap. I have already written J cap plus. Now again K cap. So for K cap, what we'll do? These will be cut and these 4 will be left, right? So 1 into minus 1 minus 1 into minus. So 1 into minus 1 minus 1 into minus 2 K cap. This is V cross plus V. So we have to solve this also. So this is minus 2 into minus 5. This is 10. This whole term is 0. So 10 I cap. Minus 5 minus 0. So minus 5 into minus j cap. That is plus 5 j cap. This is minus 1. This is plus 2. So 1, this minus 1 plus 2 is 1. So plus k cap. This is just V cross V. You have to add electric field to this term which you have obtained. This is this term. Now, what is the electric field given? 2I cap minus 3j cap. Electric field is 2I cap minus 3j cap. So these two will be added. How? 2I cap minus 3j cap plus 10I cap plus 5j cap plus k cap. So you have to add it. So 2I cap plus 10I cap, 12I cap minus 3j cap plus 5j cap plus 2j cap and only k cap will be there. Now, final step. The final step is F net will be Q multiplied to this entire term which we have got. Q multiplied to this. And charge, I guess it's 2 coulomb. So basically you will have 2 multiplied to this entire term is what? 12I cap plus 2j cap plus k cap. So this is equal to 24I cap plus 4j cap plus 2k cap Newton. This is how you have to solve it. Write down this. Okay, class. Now we'll just see the force if a single conductor is present, current carrying conductor is present. So this is a very easy derivation. Even the formula is very easy. See, a conductor is present of length L. It is having the charges going, electrons are moving upwards. So see, direction of current is always opposite if the charge is negative. So electrons are negative, obviously. So if this is moving up, so charge current is moving in the opposite direction. Now, volume of a conductor, volume of a cylinder, volume of this cylinder is what? Area multiplied to the length. So volume is area into length. No, if all the number of electrons are present, if I'm referring to all the number of electrons, means number density, not electron, number of electrons per unit length, means all the electrons which are associated. So it will be N into AL, right? N times AL. Now force is F is equal to E VD into B. Now what is meant by E VD into B? Charge drift velocity into V. Means basically this is our formula QVB only. QV cross B. What is the formula? Lorentz force, magnetic force. How do we write? Charge multiplied to cross product of magnetic field and velocity. Here the velocity that we have taken, it's the drift velocity. What was drift velocity? What was the formula of drift velocity?
Vd equals to negative EE by M.
EE minus EE tau by M. That was the drift velocity, and meaning, see, drift velocity was the velocity with which, the average velocity with which the electrons drift towards the positive end of the battery's terminal. Okay. So remember these definitions also that are also going to come in the exam. Anyways, okay, good, Rishita. Now, class, one thing. So that is for just a single one. If we have the total cylinder present, cylinder, why am I saying cylinder? Because wire is in the form of a cylinder. So this is the wire. So NaL will be multiplied to this E. Now, class, can any one of you answer out of this, these two, these four terms which I have highlighted, this, this, are they making any sense? Are they making
Uh,
any? Yes,
they give the
Rishita?
current. They give the current density. I mean
Current.
I.
Very good. Very good. It's the current, which is NEAVD. This was a very important relation when we were doing current electricity. Taha and Sufyan, you must not be knowing this because we haven't completed this part. So just wait for that. There's a formula. I is equal to NEAVD and drift velocity will be coming. Okay, Taha and Sufyan.
Yes, sir.
Okay. Now, so what we can do, we can replace this magnetic field is there, now current, and now length will come. So this is now the formula which we will be using. Actually, it is B I cross L. So this is I has been taken outside. Magnetic field, this length was left. See, here this length was already left. NAE got multiplied within the bracket. So length was already left. I cross B. This is it. But we write ILB sine theta. In most of the cases, theta is 0. So the formula which you will be using, frankly, it will simply be BIL. This will be the formula which you will be using. Like, okay, the questions I'll tell you later. Two questions are there which we'll be discussing based on this. Directions we'll be using. So I think all of you should open the cameras right now so that we can practice. Means after writing this, please open the cameras. Start writing. Okay, let's come to the questions which I was mentioning to you. See, look at the first question. Calculate the magnitude and direction of the force. Other students also please open the cameras because directions and all are needed and your right hand has to be visible. Even if it is not, the rule is that you have to open the cameras. So please follow the instructions, especially for magnetics. Now, see, length of the conductor is 10 meters. The current which is flowing through the conductor is 5 amperes. Magnetic field is 2 Tesla. So calculation part is very easy. What is the force? BIL. So BIL will be 2 into current is 5 into 10. Fine. So 5 into 2, 10. This is simply 100. Now, what about the direction? All of you, please try the direction. Tell me the direction. Try this direction. Take your right hand. Take your fingers along the direction of current. Curl your fingers towards the magnetic field. See where the thumb is pointing. Up, down, left, right, inwards, outwards. And tell me in the chat column all. Easy, very easy. By now, you all should know the directions. Take your right hand. Again, I am repeating. Take your right hand. Put the fingers. All those who have not done class, I am repeating it. So please listen. Take your right hand. Take your fingers along the direction of current. Curl the fingers wherever you think the magnetic field is being pointed. Then look at the thumb. Where is the thumb point? By now, all of you should answer. Okay, Rishita and Taha have answered. 2 students have answered. Yahya, your answer. Zaina's answer. Sidra, Khadija, where are your answers? At least try and tell me the direction. Sufyan, Siddiqa, answers please. Okay, Zaina, all Zaina, okay. This is K cap, yeah. Positive K cap.
Yes, ma'am.
Okay. So Zaina, Yahya, Taha, and Rishta, 4 students have answered. Yes. See, let's see whose answer is right. 4 answers and all the 4 answers are totally different. So let's see whose answer is correct. Right hand, current is flowing towards the right side. So I'll put my hand towards the right side. Now I can put it like this. I can put it like this. Both are valid. Where is the magnetic field present? What is this cross symbolizing? Inwards. This is the symbol for inwards. So if I put my hand in this direction, fingers won't be curled. So I have to put my hand like this. So first one was to put the right hand along the direction of current. Curl the fingers along magnetic field. So only Taha's answer is right. Upwards. Force will go up. So Taha's answer was right. Up. You can write J cap. You can write upwards the way you want to write it. Newton is the answer. This is how you have to write. You can copy down this later. Calculation part is very easy. Same calculations are here also. B I L. Calculation part is very easy. BIL. So this everybody will be able to calculate 2 into 5 into 10. So this is 100. Now class, tell me the direction of the magnetic field here. All of you should answer, not just these 4 students. Rishita, Taha, Yahya, Zaina. Not only them. Other students are also present. You also should give your answers. Khadija, you also please respond. Whatever you think is the answer, let me know. The other students have also answered. Okay. Yaya's answer I've got. Siddiqa's answer I've got. Good, Siddiqa. At least you've answered after a long time. Sufyan has answered. Again, all the answers are different. Now, Rishita, Zaina, Taha has answered. Rishita has answered. Zaina, where is Zaina? Zaina hasn't answered. Khadija has answered, okay. Zaina, I think Zaina hasn't answered. No, Zaina, uh, Taha's answer has changed. Zaina, for the second part, answer is left. Okay, Taha didn't answer. This is Taha's answer, okay? Okay, Zaina has also answered. Let us see whose answer is right. So Khadija and Zaina have answered the same. Taha, Rishita have answered the same. Sufyan and Siddiqa and Yaya have different answers. Okay, see, right hand. Okay, though even if it's your answer is correct, just follow. Right hand. Now, current is moving upwards. So I have to put my hand either like this or like this. These are the two ways which are possible, either like this or like this. Now, dot symbolizes magnetic field is outwards, right? If I put my hand like this, magnetic field is outwards. I'll not be able to curl like this. Now, magnetic field is outside, so curling it outside. So it is towards the right side. So Rishita answered it correctly and one more answered it. Taha again. Very good, Taha. Both the answers were right, Taha. And Rishita, very good. This answer was right. It is right. See this. This is right. Now try it yourselves. Both the parts when you will be writing now. Then you can. So right is I cap. I cap also, and you can write in the bracket as right. And this is Newton. Okay. Copy it down, all of you. And if you have any doubts, let's Okay, class. Now see, this was a single wire. This we were studying about a single straight conductor which was present. The formula is BI. Now there's a case in your syllabus, specifically two parallel wires if they are present. If two parallel wires are present, then what is the force between them? So force between two long parallel wires, this can come in your exam to write it as it separately. And this formula also can be mentioned. So one conductor and two, and this is not general formula between two conductors which are present. This is specifically for this case, two long parallel wires. Two means two wires are present, long means infinitely long. And parallel, both are parallel to each other, long current carrying wires. So separation between them is D. First one has current I1, second one has current I2, length is L. Now separation between them is small d. Now see, suppose I am calculating the force on 2 due to 1. So what is the magnetic field due to the first one? We have studied that long wires have the formula mu naught I1. I1 I am taking because it's the first one. 2 pi d. This was the formula which we have already studied. Now class, tell me one thing. If I am calculating the force on the first due to the second, sorry, force on second due to the first one. So BIL, now current, because I'm talking about the second one. So current will be also the second one. Length is anyway same of both the wires. But magnetic field will be first one, na? See, two wires are present and first one is generating a magnetic field that is getting influenced on our second wire. That's why we are calculating force between two parallel wires, right? So here in the second wire, I2 current is flowing, but the magnetic field will be due to the first one. So this is B1 and C angle will be 90 degree. So this is I2 L B1. Now put the value of B1. When you put the value of B1, F21, this is equal to I2. L B1 is mu naught I1 divided by 2 pi D. So see, the ultimate formula will be mu naught I1 I2 L by 2 pi D. All right. What is this? This is the force between two conductors, and this formula is important, class. See, this is very easy. Derivation is also very easy. In few steps, you'll be able to complete it. Derivation and formula, everything is easy, but I don't know why this has been repeating a lot. Recently, this has been repeating itself a lot. So it's better if you prepare yourself for that only. Now, one thing here, that force on second due to 1, which we are calculating, which is if you divide the length, like if I bring this length in the denominator, so it becomes force per unit length, that we represent by small f. Capital F means the single force. And when small f is used here, that means force per unit length, which is used. So in that formula, L will not come. Length won't come here. So mu naught I1 I2 by 2 pi. And one more thing, class, if you're calculating the force on second due to first, it will be negative of first due to second. This. So this is just like the action reaction combination. This I'll tell later, or yeah, this I'll tell later. First, just copy down this part, then I'll tell. Start writing. Okay, done. Then see, there are two directions which are possible in this case. So no right hand rule, nothing. You just have to remember. See what all directions are possible. Only three directions are possible if two straight wires are present. One possibility is that both the currents are flowing in upward direction. Second possibility is that both the currents mean current in the individual wire. But since there are two wires, so that's why I'm referring to as currents. So currents are flowing downwards. One is upwards. Both are flowing upwards. Second, both are flowing downwards. One possibility is one up and one down. That's it. So just remember, if they are moving in the same direction, either upwards or downwards, so conductors will be attracting each other. They'll be moving towards each other. Then you can analyze which one is moving towards left, right, I cap, J cap. That way you can adjust yourself. And if they are moving in the opposite direction, so they will be repelling each other. So they'll be moving apart. So according to that, you can fit in the direction. So this is easier in this term also, that you don't have to fit in the right hand thumb rule here and use it and utilize it. All right. Sometimes a question comes to define 1 ampere. Now, 1 ampere, you can always define it as the charge, 1 unit charge flowing through 1 second is also 1 ampere. Now, some questions are mentioned, define 1 ampere when flowing through two parallel wires. Like, it means straight away your mind should come to here. Now, formula is F is equal to mu naught I1 I2 by 2 pi d. So we say I1, I2 both are equal to 1 amperes and the distance d is 1 meters. So force will be mu naught is 4 pi into 10 to the power minus 7. I1 is 1, I2 is 1 divided by 2 pi and d is also 1. This makes it 2. So force is 2 into 10 to the power minus 7 newtons. Means what? 1 ampere. How can you define it? It's the current. See, when you are defining 1 ampere, see, it is the current when flowing through two long conductors. Whatever we have done, just write it in words. 1 ampere is the current when flowing through two long conductors separated by 1 meter, gives 2 into 10 to the power minus 7 Newton of force and can attract or repel each other. That's it. This is how you can define it. 1 and 2, these two questions we have to do. Basic questions are these. First one, let me discuss. First one, second one, you can try by yourself later on. Now, both the currents are in the same direction. So, this is how you decide the direction. Force per unit length on conductor 2 due to 1. First part means F2, 1. And see, per unit length is mentioned. Already length is not mentioned. So, we are not even worried about it. So, mu naught I1, I2 divided by 2 pi d. Mu naught is 4 pi into 10 to the power minus 7. I1 to I2 is 10 divided by 2 pi. D is 2. So 2 cancelled. From here 2 is left. So it is 2 into 10 to the power minus 6. This 10 is also here now. Okay, so we are calculating on 2. So where is 2 moving? 2 is moving towards the negative I cap, means negative x-axis, this much Newton. Second part is very easy. You know the first part. So F12 will be minus 2 into 10 to the power minus 6. Direction is just I cap Newton because both are negative of each other. Write it. And if you have any doubts, let me know. Okay, class, this will continue in the next class. I think most probably you'll be having an extra class on Saturday, 1 hour. Let's see.